Yeah, I'm very happy to be here and present our very recent work in this workshop. So essentially, what I'm going to talk about is some factors that might affect our social decision. Okay, so what is a social decision? So let me start off with an example. Say at the end of the almost the end of the workshop, you guys decide to go have dinner in a restaurant and skip the IMSC guest house food for once, right? So how do you choose the restaurant, right? So it will depend not only on your own individual preference, but you have to listen to the others' opinion as well, what kind of food they like. You might want to go and check out the reviews in Zomato or Swiggy, and then look at the cost, which is also important. If you know, you have to figure out whether the restaurant is affordable for you or not. So many factors, and finally you come to a decision. Okay, so this is an example of a social decision. So this is something we have just started working in this field, and we are interested to know essentially what are the factors that impact your social decision making. Okay, so unlike individual decision, so individual decision is where you take a decision based on some stimulus or some event, some occurrence that happens, right? So it just depends on you. But social decision, on the other hand, it depends on a variety of factors apart from your own individual decision. You have to listen to others' mood, emotion, action. Okay, there are a lot of factors that influence your social decision. All right, so that makes social decisions quite complex and dynamic. Okay, so what are the sort of key factors that influence social decisions? So firstly, of course, you have to listen to others' opinion. Secondly, you have to check out whether the others are being fair in their judgment or not. So fairness is an important criteria. All right, if you feel that the other people are not being very fair, you tend to be little antagonistic, and sometimes you tend to punish also. All right, then you have to cooperate and trust, okay, the others, trust their decisions, or if you don't, you might choose to defect. You abide by the social norms and cultural norms that you grow up with, so that has an unconditional effect, unconscious effect in our social decisions. All right, you also take into account the emotions of the others. Okay, so there are a lot of factors that go into the social decision making. So typically, if we want to systematically study social decision making, we resort to game theory. All right, so is there anyone who has absolutely no clue about game theory? Okay, good. All right, so essentially you can think of game theory as sort of a mathematical model using which we sort of study these kind of social behaviors. Okay, there are a lot of popular games that you might hear, like prisoner's dilemma, dictator's game, ultimatum game, like that. So based on that, we would sort of try to infer how we make decisions, social decisions. Okay, so here what we are using is something called the ultimatum game. So who all know ultimatum game here? So essentially in ultimatum game, so it's a two-player game. There is a proposer and a receiver. Okay, so the person who's conducting the game, this lady with the specs in this case, okay, she is the conductor, and these two are one is the proposer, one is the receiver. Okay, so she gives this $100 to the proposer. All right, the proposer has the job of deciding how he is going to split the money. What is the ratio? Typically, you keep more for yourself and give less to others, but how less, that he gets to decide. Okay, but the receiver on the other hand gets to decide whether she will reject or accept the offer, whatever is being offered to her. All right, so if she accepts the offer, whatever split the proposer decided, both gets the amount decided by the proposer. However, if she rejects, then no one gets the money. Okay? Is there any confusion about the game? Okay. So, what is important is that typically this has been played for like under variety of population, variety of professions, a lot of research going on in. Yes, it's all open. So the proposer will tell you how much he is keeping for himself, how much he is offering you. So if we are being completely rational, then we'll always accept because we're getting money, no matter what, right? But that is not what happens, okay? So oftentimes if we see that the proposer is keeping lot of money for himself and offering pittance, we tend to reject the offer. Because you have the power of rejecting the offer. If you reject, no one gets, right? So the receiver, so it's sort of an interactive game, right? Both have power. So the proposer can decide the split, the receiver can decide whether to reject or accept the offer, all right? So this is the ultimatum game. So you want to be very clear about the game, otherwise we cannot move forward, okay? So there's two player, proposer who decides how to split the money, receiver who decides whether to reject or accept the offer, right? So what are the factors that influence the social decision under the pretext of ultimatum game, okay? So emotion and fairness has been consistently a very key motivating factors for rejection or acceptance by the receiver, all right. So what I mean by fairness is typically the amount of money that is offered, okay. You can offer very like high percentage or very low percentage of money. Typically about 40 to 45% of the money if you offer to the receiver, it is sort of the overall threshold in like almost all populations. There are variance, of course. So it has been seen that there's gender difference. So guys tends to be more stingy than girls. There's difference between professions. So students tends to be more stingy than salaried person, which is normal. And then as you grow old, you tend to be more benevolent and give more money. So there are these different types of like it depends on the population on which you are testing this game, okay. So what is generally seen is that in case of emotions, it's a happy phase, you tend to get more acceptance. However, it's like a negative emotion like anger, disgust, sadness, then it often leads to rejection, okay. So now, yeah, that's what I'm coming. So this is in general, I'll talk differently on different emotions on proposer and receiver, okay. The other thing is that if you make a lower offer, if you are offering less money, you typically take more time to come to a decision. However, if you offer more money, you tend to decide very quickly, okay. So this time that you take to decide, so in psychophysical task it has got a name, it is called reaction time, okay. So this reaction time is very important parameter for any sort of behavioral experiments. So what is reaction time? Reaction time is the time you take from looking at the stimulus, whatever is being presented, say the offer, till you come to a decision and press some key to make your decision. So this particular time is called the reaction time, right. So based on the reaction time, there are a lot of theories that sort of guide our neural mechanism that results in this reaction time. So there are a lot of like known theories, and some of them have been verified using neural data as well. So typically it has been seen that we decide the reaction time is quite short if you give more money, reaction time is longer if you give less money.
This is on receivers.
Sorry? This is receivers. Receiver has to do all the, proposer just splits the money. It's the receiver who takes the final decision. Yeah.
Does the initial amount matter?
Sorry?
Does the initial amount matter?
Initial amount matters. Initial amount matters. It has been seen that I'll come to it. So if the amount of money is very low, then the effect is not that much. But if the initial amount is substantial, then you see more pronounced effect. Okay. The other thing is you typically take more time to reject, but you accept more quickly. Okay. So when there's a rejection, you think about it for longer time. Okay. So in this study, what we are interested in is the receiver proposer dynamics. Okay. What happens? How does the receiver come to the decision based on what factors? Out of which we are primarily interested in emotion and fairness. These are the two factors that we would be interested in. Okay. So just going back to bit of a few previous studies. So say we have a proposer and here we have receivers. The receiver here, the proposer sees different moods or facial expressions of receivers. Okay. So one is happy, one is sad, one is disgust. All right. So it has been seen that the proposer tends to offer more money to a happy face and less money to a disgusted face. So can you tell me what happens to the proposer if she sees a sad face? What is your sort of intuition? More. Why? No, happy is more. What about, no, proposer is neutral, right? The receiver expression is happy, sad or disgust. So if the proposer sees a sad face, will he offer more money or less money? Less money. Or more? How many more and how many less? Let me see. More? Okay. Actually it is indeed more. So now there's things like compliant expression and non-compliant expression. So non-compliant or little bit antagonistic expressions or emotions are like anger, disgust. Okay. And sad somehow comes to a more compliant expression. So you can also think of it like you are feeling taking pity and giving more money. Okay. Happy is sort of understood, sad is a bit counterintuitive, maybe counterintuitive. Right. So this sort of result is more or less consistent and established. However,
I would have thought the opposite, because sad means that the person is in need of money. Happy, maybe he's happy.
Happy is just positive, right? So you tend to, like, people don't want, negative emotions.
But I would argue, why would I give him money? He's happy anyway.
Yeah.
Just playing devil's advocate.
Yeah, but it might happen, but it has been seen that almost happy and sad go sort of hand in hand. So generally, but when we reverse this, so when the receiver sees this different expressions, yes.
Proposer also thinking of, is the other person likely to accept it or reject it?
Sorry?
Is the proposer also thinking of the receiver likely to accept it or
Yeah, so this is not a one-shot game, so you keep on playing. Like what we were doing is like you're playing this many times. So of course, depending on, there's a sort of learning for both the proposer and the receiver. Yeah.
So is it possible if the proposer offers an amount and the receiver does not like it, so the proposer can change it immediately?
No, that is like to show this is one-shot game. That game is lost. He doesn't get money. Then he plays again. Then he can change it.
Okay. And how many times usually do you?
No, this is depends on how you're playing the game. So for our experimental pipeline, so we have many conditions. Each condition there are sort of 2 times you can do this. But it's all like independent. So proposer one trial, only one chance. You then go to the next trial. So you have like blocks of these trials. Okay. So here actually the result is mixed. It's not like totally consistent. So in some studies it has been seen that you tend to, if you see a happy proposer, you tend to accept, whereas if you see like an angry or disgusted proposer, you tend to sort of reject. Okay. And there has been a study where you sort of change the emotions systematically from happy to angry, and your rejection, your acceptance rate also decreases systematically. Okay. But there are studies that actually show that the emotion of proposer doesn't affect your decision making. Okay. So we wanted to study this particular problem and also study the neural correlates. So since we have in our lab an EEG system, so we also measure the brain waves when the players are playing this game. Okay. So this is the essentially what exactly our aim is. Let me make it clear. So we are interested in two factors: emotion of the proposer and fairness of the offer. Okay. So since we are so happy and sad are sort of included in the same bracket, we chose to skip sad. We only have happy and disgusted. Okay. And we also have neutral expression as a control, and we have 3 sets of offer. Okay. So we give $100 to the proposer, and then the proposer can split it as 80-20, that is a low offer, 30-70, that is an intermediate offer, and 60-40, that is sort of a high offer. Okay. Yes.
I have a different question. So the receiver knows how much the proposer actually gets.
Yes.
So this is kind of, I mean, in this case, both are equal powerful, right? Because receiver can claim I need at exactly 50%, otherwise I will not accept.
No, receiver cannot claim.
Well, that is a claim means in his mind.
In his mind he can claim, but the offer lies with the, you can always reject, you keep on rejecting. We had one player like that who rejected everything.
So in general, in a company, let's say, how much the CEO gets, that does not know the lower employee, right? But here the receiver knows how much the proposer gets.
Right.
Right.
Yeah.
So
it is no.
In this case, both are equal powerful in my sense.
No, but equal. But typically, the proposer is never that benevolent that he or she will give you, more than or 50%. They always keep more for themselves. So there is a slight. There's not like they're equal, but there's difference among equals, something like that. Because the decision always lies. The power with the receiver is he can choose to reject everything.
Okay.
Then you are forcing the proposer to give you more, if the proposer wants. Now here, so we have this 9 conditions essentially. So we have 3 emotions and 3 sets of offers. Okay, and then for each emotion we have these 3 kinds of offers. Alright. So in our experiments, what we did is we only had the receiver, who were all ICER, Kolkata graduate and undergraduate students. Alright, and they believed that they were playing an interactive game with someone who is from some other Indian institute or university. So we sort of created a make-believe situation where we showed them their webcam clicked their pictures, and we also showed pictures clicked by webcam for the proposers. Actually, there were no proposers. The proposers were all determined by us. Okay, but the receivers did not know that. The receivers thought that they were playing an interactive game with someone in some other institute. Okay, and we checked that afterwards, and they didn't doubt it. So that being said, so the main objective before I come to the experimental paradigm is that we want to check the effect of emotion and fairness on receiver's decision making. Okay, so the emotion, proposer's emotion and his fairness of offers on receiver's decision, And also because I told you this reaction time is very important in behavioral data analysis. So we want to look at the reaction time under these two factors and see how it changes, and then can we formulate some theory of how we are coming to this decision based on the reaction time. And we are also interested to see whether there are individual difference between people. Are they different groups of people using different strategies to come up with this decision? Okay, and that we do using statistical modeling. And finally, we also have the brain signals when they are making these decisions, the receivers. Okay, so we analyze that and try to find markers for emotions and fairness under this experimental paradigm. Okay, so this is how each trial looks. Okay, so you start off with, where did I keep this? Okay, never mind. You start off with this fixation. Yes.
How are you ensuring that the proposer is fairness, like that fairness is how it is ensured?
Oh, we are giving the offer. There is no proposer.
So that's
We are ensuring that the offers are like varies equally, high, medium, low. These are all balanced. Okay. So for each trial, this is one trial. You first start with this fixation cross, where you're supposed to look at this cross, and you have to be absolutely still for the experiment because we are recording your EEG, otherwise there will be a lot of noise. And then you see the proposer's face showing one of the three emotions, either neutral or disgusted or happy. Okay, and you see that for 1 minute. And then you see the offer. For example, here keeps 70, offers 30. Okay, so that means you are getting a sort of medium intermediate offer. Okay, and then you have the receiver can either choose to accept or reject the offer. Right. So this goes on for 2 minutes is the maximum time. If you don't respond within 2 minutes, like you don't get any money. All right. So, but you can respond before any time before 2 minutes. Okay. And then the screen becomes blank again, and then again it repeats. Okay. So this experiment, we have all these 9 conditions, right? And there are 20 blocks. In each block, there are 18 trials, 2 belonging to each condition. Okay. So happy low, happy medium, intermediate, happy maximum, and 2 such trials. So that is one block. You do 10 block, and then you mandatory take a break for 2 minutes, then you take the remaining 10 blocks again, right? So we do so for behavior, probably don't need so much of data, but for EEG, the more the merrier. So that's why it's typically, if you just have behavioral data, you will probably have less number of blocks. Okay. So we had total of 360 trials, and there are 9 conditions. So we have 40 trials per condition overall. So as an output, we have their behavior, say their social decision, whether to accept or reject each trial. We also have the reaction time. Okay. And in the EEG data, we have 64 channel EEG signals, where we do a ERP analysis, essentially this event related potential analysis. For each condition, we take all the EEG waves, we take the average, and then we find the like known ERP components like peaks and valleys. All right. Okay. So any questions on how the experiment is run? Okay. So just to avoid any confound, we only took male students, right? So that we could have taken female students also, but unfortunately the availability of female students is less compared to male at ISER Kolkata, although we are improving, but it's still a problem. So we stuck to male. Oh, so that is sort of, you need so that there is no after image. So of this, sometimes it persists. So we need a sort of balancing before you refresh and start again. So this is like a standard paradigm in EEG experiments, that afterwards you don't start immediately, you don't go to the fixation screen again. Yes.
Have you tried different time, let's say?
Different times. Yeah, so 1 minute is sort of a standard time and 2 minutes is the maximum. Typically you decide within 750 milliseconds to 800, like 1.5 seconds is probably okay. Like not minutes, sorry, seconds. These are not 1 second, 2 seconds. Okay. So typically it has been seen that you need about 1.5 seconds, and as you start playing the game more, there's a learning effect. The last blocks you finish up more quickly than the initial blocks. Yes.
Why was the high offer set at 60-40 and not 50-50?
Yeah, because that is not how in reality the games are played. You never see, so this is based on all like real life ultimatum games, and it has been seen that you never have such a benevolent proposal offers.
Also, what if the participants already knew about the game, and that would like bias intelligence? They would know that if they pressed yes, they would get money like all of the trials.
Yeah, so the participants knew what ultimatum game is, because otherwise they knew that they will be given some offer. If they accept, they'll get it. If they reject, no one gets it. That's what they know. And we chose first year students, first year BSNS for this, so that we try to limit their too much of exposure to game theory.
Were they actually given money or?
Yeah, they were actually given money, but not like $100 for each trial, then we'll go bankrupt. But it was commensurate with the amount they earned. So some percentage of it they got. But you have to give them money, otherwise no one will do your experiment diligently. So now let us look at some results. Okay. So this is the performance when you have high, like H is happy, D is disgust, N is neutral. So what we see is as you increase the offer, right, your acceptance increases. So for the highest offer, so you see almost 90% acceptance for happy, followed by neutral and then disgust. Okay. And similarly, for the lowest offer, the lowest acceptance is for, and the highest rejection is for disgust and low offer. Okay. Yes.
How many trials are coming?
This is on total like 360 trials.
No, as in while rejected, do they know initially that there will be more 350 trials after
Yeah,
that?
they are told that they have to play this game for 20 blocks. So typically, as I told you, so higher acceptance means lower reaction time. So if you take a look at the reaction time, so reaction time we typically take the log transform of it so that it follows normality. Okay. So here again it's very similar. If you see the lowest time is for happy, actually it's like the highest time taken is for low or for disgust, okay, and vice versa. So the next plot is better if you see. So here in purple are the acceptance rate, like the reaction time, and in pink are the sort of rejected rate. You can see if you check, so these are the histograms, if you check the distribution, you can see that the mode, so the maximum point for the acceptance comes earlier, right, and the rejection comes later. And if you also see that the rejection is much more when you offer them less money, and the rejection practically vanishes if you keep on increasing the offer.
But it depends, it seems to depend way more on the offer than.
Exactly. Prima facie, that is how it looks. Okay. So this is the raw result. Now let us do some statistics and see exactly if that is the case, if they are just guided by offer. Okay. So here are this acceptance rate for these three emotions, and we did, and this is the corresponding reaction time, which is just the inverse. And what we see is that actually for the acceptance rate, it's not statistically significant at all. This is like a 3/3 ANOVA. But in the reaction time, there seems to be some difference between happy and disgust and neutral. Okay. So there is something, but it does not show up in the final behavior. Okay. So, we also did this interaction effect between emotion and offer, and there seems to be none, both for reaction time and offer. Okay. So, now if we sort of just look at the offers and not the emotions, we club all the emotions together, then what we see is that indeed there is a very significant effect of offer, both for low to intermediate and intermediate to maximum. Okay. And the same story for the reaction time. This is always the like inverse, reaction time is always the inverse. Okay. And what we see is that there is also a learning effect. So, these are the block numbers. Okay. So, as you start playing this game, you sort of learn and you finally come to a strategy and then you sort of tend to plateau a bit. Okay. So, what we know from this is that the emotion does not seem to play much role, looks like. Offer seems to be the guiding force for decision making, but there seems to be some sort of reaction time that is involved in emotion, so to speak, because if you go back to the previous plot, so the reaction time between emotions were significant. Okay. So, we need to delve further, all right. So, then what we do is, in order to study this, and we also know that this block number has an effect. Okay. So, then what we do is we turn to statistical modeling of the data. So, what that gives us is, I will tell you in a minute. So, our data, when we are doing the statistical normal analysis using ANOVA, we are sort of assuming that the observations within each category are independent, but that is, for us, that is not strictly true, right. So, we used a linear mixed effect model, which sort of, because our data is little bit nested. So, I will come to the nested structure. So, we use a linear mixed effect model and try to predict or try to model the decision, accept or reject per trial basis. And we know that what are the dependencies, we know that it depends on reaction time, it depends on emotion, it depends on offer. That is our assumption. Then we will see whether it really, looking at the coefficient, we can see whether emotion really has a part to play or not. Okay. So, now the problem is that because the way we have done this, our reaction time, as we have seen, also depends on offer and emotion, and the decision depends on offer, emotion and reaction time. So, the reaction time, this offer and emotion is coming twice, right. So, that presents a confound. So, what we have done is, we have done a 3-stage model. In the first stage, what we do is, we just model the reaction time using the block index per participant, emotion and offer. Okay. So, just do not go into too much of the details, just know that this is a linear mixed effect model where we have random intercept and random slope, where it is dependent on offer, emotion, block index and the participant. Okay. So, once we have this reaction time, estimated reaction time, we subtract that from the actual reaction time which we have. So, that gives us the residual reaction time. So, why are we doing this? Yes, I is participant. So, its subject. Okay. So, the residual reaction time takes away the contribution of emotion and offer, and then we use this residual reaction time to model the decision, so that it is not counted twice. Okay. So, now we model the response, so whether accept or reject, using the residual reaction time, offer and emotion. Okay. Very similar setup as the reaction time, but now instead of the actual reaction time, we are using the residual reaction time. Okay. So, we do this model and then we try to see how well it fit our data or not. So, it fits quite okay actually. So, if you look at the adjusted R square, it is almost 0.75, and the QQ plot is also good, but you can see towards the end it is not a very good fit. Over the middle it is a better fit. So, we also try to predict this by splitting our data into 80% training and 20% testing, and we found out that the area under the curve, or the classification rate is close to like it's very high, it's almost 98.9%. So the model sort of captures, it's a good fit to the data. Now what does that is fine. Now how do we use these models? Okay. So what we are interested in is that in the models we can get this coefficients for emotions, coefficients for offer, and then check out whether these are different, are there similarities between groups, is there an actual effect of emotion, or emotion as it looks in the initial data analysis is just not there at all, everything is based on offer, right. So we can do all this, we can plot the coefficients of say happy and disgust, okay. So this is disgust, that's happy, and this is the coefficient of offer, and these are all the subjects. We have 40 subjects, we actually have 50 subjects, but some of them couldn't complete their EEG, went bad, so we stuck to 40. Alright, so here what you can see is that actually some of them can be clustered in groups, okay. So that's what we just did, we just used agglomerative clustering and clustered them into 5 groups. And how are we naming this? So this small group of green there over there, that is strictly emotion driven. Then this yellow here is moderately emotion driven. So you can see the coefficients like it's more towards happy coefficient, right. Then on the top, that is strictly offer driven, the light blue is moderately offer driven, and the purple is generic rational. So they are not influenced by pretty much either offer or emotion, okay. They are like, if you just play it, they are always sort of accepting or tend to accept everything. Now it will be interesting, now that we have got this kind of groups, now it will be interesting to see actually. So we have this kind of what we call the rationality triangle. So we have these like different groups and they sort of form, that is where they lie, okay. So now, yes.
Why have disgusted and happy been plotted in different axes? Is it possible for both to coexist in a single image?
Yeah, but that won't make sense much,
Yeah.
because you either like being happy or not. So that's why we have all this for each individual observer. We can extract the coefficients for happy and the coefficients for distress.
Okay.
So now what we would like to know, that is this group, does it make sense neurally, are they behaving differently, or is there like their inherent underlying mechanism that they are using is different from the other groups. So for that we use a well known model called drift diffusion model, okay. So that is used quite a bit in cognitive psychology and neuroscience. So it's a model of how people come to decide. So it is based on actual neuroscience experiments with random dots, okay. So this is essentially an evidence accumulation model. So it is assumed that you have evidence which is noisy, okay. You have evidence that is noisy, you keep accumulating this evidence and you reach a threshold which is say the A, and then you come to a decision whether to accept or reject, okay. So this is an accumulation of evidence sort of based model where we only have the reaction time, okay. So there are 4 important components of this. First is the drift rate, so V, how fast you are coming to a decision. So that tells you about the task difficulty, for example, or in our case you can think if you have high offer, you might come to decision soon, right. You will have a greater V compared to low offer, for example, okay. And then you have the starting bias or Z or Z. So that tells you that whether you are predisposed prima facie to any of the decisions, okay. So if this Z lies exactly in between these 2 boundaries, this is accept, this is reject, then there is no starting bias. However, if the Z goes more towards A, then you are sort of predisposed little bit towards accepting the offer, alright. So in our case we thought that it might be, if there is some starting influence of emotion, then say for happy phase you might have your starting bias bit more towards acceptance, okay. That we can figure out once we run the model. And so A and 0, these are the 2 decision boundaries, so accept and reject, okay. So essentially we simulate this, and this the way this distribution of when the evidence is accumulated and you first reach the decision, that is, there is a well known complicated distribution for this. This is known as FPTD, so first time passage distribution. Okay. So, there is a complete probability distribution for the time when you first come to a decision. So, essentially what we do is, in our model we have to estimate these sort of this drift rate, starting bias, decision boundary. Okay, and how we estimate is we used a hierarchical Bayes inference. Okay. So, just Bayes inference is pretty much you formulate a model, you give the priors and the likelihood, and it gives you a probability, posterior probability distribution. So, unlike the classical inference where you just get a probability, posterior probability, here you get an entire distribution. Okay. So, this is our Bayesian framework where these are the priors that we give, and this is the likelihood. FPTD is that first passage time distribution. So, do not worry about all this. So, essentially we run this, and what we get are the coefficients of the drift rate. Okay. Say for the first figure here, so the higher the drift rate, the quicker is the time for decision making. So, you see the most important contribution seems to be from strictly offer driven group. Okay. You have like more offer, you come to decision more quickly. Okay. Followed by strictly emotion and moderately emotion group, and then the generic rational is almost close to 0. Alright. So, it seems to be like the grouping seems to make sense, whatever the cluster is. So, we also in the drift rate there is a coefficient of emotion that we can see. What we see is the coefficient of emotion is only sort of significant for strictly emotion groups and not for others. So, the part emotion plays an effect only for the groups that we have selected which are driven by emotion, not for the other clusters. Okay. And we saw no sort of effect of emotion in the starting bias. So, we actually see no evidence. Initially we thought that we will see some starting bias of emotion, because they right away before taking the decision they are looking at the emotional phases. But from the drift diffusion model, it looks like the emotion does not have a role to play in general for most of the participants. Okay. So, we were a bit confused that what is happening, are they not registering the emotions at all, they are just focused on the offer, right. Luckily for us, because we have this brain data. Okay. So, and we also recording this EEG data when they are seeing the emotions, the face. So, what we can do is we can actually look at the EEG data when the face appears and see whether indeed there is some effect of face or not. Obviously, looks like in the behavior there is almost no effect, apart from a few clusters which responds to emotions, but overall there seems to be not much of an effect. So, what we do is we analyze this. So, we have a 64 channel EEG system. So, this is the sort of placement of the electrodes in the your EEG cap. There is a cap where you have electrodes, and there are like very standard way of putting the electrodes. And after that what we do is we take this 40 trials per condition. So, you have 9 conditions, we have 40 trials, and then we take the average. Okay, that gives you what is known as the ERP, or event related potential, and then we look at this peaks and valleys of the data. So, these are the EEG data, this is the topo plot, these are for happy, disgust, neutral, these are the way how the brain data looks. But what is important is you see this negative peak there. So, that is called N170. So, anytime you see a face, any face, whether you are focusing on the face or not focusing on the face, if you see a face roughly 170 milliseconds after you see the face, your ERP will have a very strong negative peak. That is called the N170. It is a very strong response. So, you will always get it. Okay. What we see is that across all participants we see this N170 peak, but for happy participants that see unhappy face, this negative peak, this N170 is higher. Okay, and that is how it should be. it is consistent with the other like literature in phase. Higher means the amplitude, the negative peak is more, goes farther down, yes. So we see that, and we see that this effect is more pronounced for emotion driven participants. So the next plot is the same one N70, but for the two groups that respond more to emotions. Okay. Now there is another component that is looked in literature called LPP. So that comes bit later, so it's from 400 to 600 milliseconds. So it can be divided into early LPP, medium LPP and later LPP, and that sort of corresponds to extended allocation of attention. Okay. So you are paying more attention to it, and we see that both in the middle and the early LPP it is quite significant. Okay. Now, but for the emotion driven participants we do not find this significant, because probably they have already registered the emotions before in N170 itself. That is why it is not showing up in the emotion driven participants. Okay. So, this then from the EEG plot it appears that indeed they are registering the emotions, they are looking at the face and registering the emotions, but from the behavior it looks like they are acting against it. Okay. So, this is the neural correlates when the offer appears, that was when the face appears, this is when the offer appears. So, in offer appears there is a component called FRN, so frontal related negativity. So, that is sort of a punishment marker. Okay. So, you have negative peak if you do not like something. So, for happy, for example, FRN should be less, and that is what we see for emotion driven participants only and no one else. And for strictly offer driven participants we see something called P300, which is sort of gives you confidence and it is sort of an oddball, so something that pops out. So, we see these two not for all the participants, but for just the groups. So, essentially then if we come to summarize whatever we have learned, is that fairness seems to be the guiding factor, not emotion. Okay. However, we are registering emotion, that is important to know. We are registering emotion but choosing to ignore it and giving more priority to fairness. Okay. So, it is perceived but not acted upon, and we can find, however, there are quite a bit of individual differences in the way that we decide. So, we have seen clusters of individuals that respond more to offers, clusters of individual that responds more to emotions. Okay. And we also validated this behavioral findings using the EEG analysis. Okay. So, that is more or less what I have to say. So, these are the references for most of the work that I said, and lastly and most importantly, most of the work were done by the two students of mine, Rudra and Shorin, and we also have statistics faculty Shattoki, who helped us with some of the analysis. Okay. With that I will stop and welcome to ask any questions.
Questions? So
Yes.
how do you plan to, oh sorry, go ahead.
In the experiment, while showing the face of the facial expression of the proposal, if there was also an amount displayed alongside the same.
So, you want to give the offer as well as the face together, then
not necessarily the offer, but to convey how much they might already have in terms of winnings.
oh,
That be a
winnings.
useful proxy to check of that it's really about fairness. That if they have much less than what the receiver.
Oh,
the
that is an
subject of
interesting
experiment.
question. Yeah, we can probably do this for future experiment.
And being able to track it.
Track it. So, how much amount is accumulating? Yeah, that makes sense. The other thing I forgot to mention is oftentimes it is seen that there is also an effect of how attractive the face is, right? So you might want to, so what we did was we did a post experiment analysis where they rate their attractiveness just to show that they're not being, you know, partial to some face and others. And so there's something called this handsome bias. So we show that in our experiment that is not the case. So all were equally attractive or unattractive, whatever the faces were shown. But it has been shown that you typically end up, if one, that's why you don't mix the gender, because then you are confounding it with another thing. So also it has been shown that if you know the observer, you tend to be more benevolent. Otherwise, if it's unknown or if you just show just say an emoji or something, then you tend to be more stingy. So there are like this lot of factors that play a role. Yeah.
Also, is it possible that emotion could be like a longer term thing? So because we have been showing lots of different emotions in short term.
Right.
Instead, what if a certain participant had a continuous stream of only disgusted faces? Would that like over multiple
So that,
trials?
yeah, so then that will prime the participant, he will not get the instantaneous response. Yeah. So that will sort of, you are conditioning the participant or manipulating the participant. So that will have an effect. So you have to, it has to be orthogonal.
Yeah.
The fairness and emotion has to be orthogonal.
Yeah, so I was thinking of extending this to any other
Games.
like for example, traveler's dilemma.
Traveler's dilemma. Yeah, I mean, yeah, I just need some more students. But yeah, this is the first time we worked on this and it seems pretty, we thought we will get some effect of emotions. We got some, but overall it was more or less offer driven. Yeah. But that is what, and another study also showed the same thing. So again, you questioned about the amount of money. So in another study which was just behavior, they also had similar result as us. Where they gave, like per trial they gave $100, here we gave 100 rupees. But, and they also found no effect of emotion. Whereas there's some study where they gave, say, per trial 30 cents or something. There actually, they saw that emotion had more effect. So it depends. If the offer is substantial, then people tend to focus on offer. If the offer is not that substantial, the difference between the offers, then you probably tend to focus more on emotions.
Any other questions?
Yeah.
That same explanation, instead of dollars and cents during the experiment, if it was just units, arbitrary.
It's all units only, like they don't get, so these are all, they're not getting 100 rupees per trial, as I said. So it is just a hypothetical 100 units that is given to them. And then they divide it. And based on whatever they are keeping, some percentage of this, they have some like fixed amount for participation, say 200 rupees. And then the remaining is a percentage of how much they earn.
What do you mean by percentage?
So say you are playing 360 times, so each time it's 100 rupees, right? If you have maximum, then 40 times 360, then it will be a lot of money. I'll go bankrupt. So what we do
And you have
is,
students clamoring for doing this.
yeah. So what we do is typically they earn about 500 to 600 rupees on an average per experiment. So we have some percentage cut off that total score, some percentage of that they get, some fixed percentage. Well, there were a few students like those we call generic rational, they accepted whatever you get them. So straight away they need money, they don't care.
Maybe they know game theory.
Yeah. So we tried to limit that by only taking first year students, but again first year students are also quite, knowledgeable nowadays.
Maybe they googled it.
Yeah, they might. We don't say this name game theory and all to them. We just say that this is how, this is an interactive scenario where you are sort of interacting with another, student from another university and he offers you, you accept or reject. But yeah, I'm sure like they
You
talk
do
amongst
like a
themselves.
pre-selection questionnaire where you ask them if they have any experience.
Yeah, we did that, and they mostly said no. But
Yeah, but maybe they are gaming it.
yeah, they are. They probably are. I'm sure like at the end of it, they are already. We told them not to talk to your friends and all, but I'm sure they talk.
Are there any other questions? Okay, so if not, let's thank Mr. Das.